We have Wesley to talk about data quality and analytics, a statistician's viewpoint. So please welcome Wesley, everybody.
Hey.
Oh, thanks.
Hey. Oh, I guess it.
Thank you very much. So just wanted to, first of all, thank the organizers. This has been a really, really interesting conference for me. This is not my typical conference. I'm really a statistician, a data geek, stat geek, whatever you want to call me. A lot of food for thought, though. So, who am I? Okay, as I said, this is not my typical conference. I'm a statistician. I've been working at Statistician for over 35, well, close to 35 years. Lots of experience, done a lot of stuff with data. I am not a CDO. I am not a data scientist. Okay, I want to make that perfectly clear. I'm the Director General of the Modern Statistical Methods and Data Science branch. So you're thinking, okay, what do? We have a lot of what we used to be called, well, we still are called survey methodologists. StatCan, for many years, relied a lot on surveys. Over the past 5-10 years, we're trying to move more to alternative or administrative data. I like to call us now statisticians. We're going back to our roots. What do we do there? We have some data scientists as well. I would be remiss to say that. Christos is actually at StatCan. He's the director of the Data Science and Innovation Division. He spoke yesterday on the panel. What is our role? Well, a lot of the times we're referred to as guardians of quality. What our role is to ensure that when we put a number out, CPI, unemployment rate, whatever we put out, I'm not going to say that, yes, the inflation rate was exactly, I think it was 1.6% last month, I can't remember, under 2%. I can't say that it's exactly 1.6%. What I can say, though, is the process that we use to estimate that number is defendable. Okay? So if our chief statistician gets called down to the Parliament and to the Commons or one of these committees, he's not going to say, it's 1.6%. He'll say, no, everything that we did to produce that number is based on scientific principle and statistical rigor. That's what we do as methodologists, data scientists. So I said that we produce our outputs are defendable. So when I started thinking about this, it's been a long time since I've been in school. Data analytics didn't really exist when I was in school. We used to do data analysis. So I said, okay, I need to figure out what is data analytics. So I told you, not a data scientist. I didn't go to ChatGPT. I went to Google. Okay, I'm old school. Okay, I found this one, Investopedia. I'm not saying it's the best. I think it was the first one that came up. Okay, so I'm not plugging Investopedia at all. So according to Investopedia, data analytics analyzes raw data, look for patterns, and tries to make conclusions about that data. Yeah, sounds pretty good. The goal is to increase efficiency and improve business performance. Okay, and you're looking at patterns in the data. Okay, I think most of the people in the room know this. They talk about some of the analytical approaches: descriptive analysis, diagnostic, predictive, and prescriptive. And as you all know, and I could be wrong here, but results are typically shared through visualization produced in either Power BI, Tableau. There's probably many other things. There'll be something new next month, and it's going to be the greatest, and so forth. Okay, that's the way technology is moving these days. So then I said, okay, let's see what they say about statistics. So according to Investopedia, statistics involves the collection, description, analysis, and inferences of conclusions from quantitative data. I'm like, oh yeah, okay, I can see myself in there. It draws reliable conclusions about large groups, general events, from small samples, or I'll say smaller samples. Don't want to get the impression we can do this with a sample size of 3 or 4. Okay, you need some sample. To me, and maybe this is my background as a survey statistician or a survey methodologist, the most important thing is these smaller samples represent a larger group. Okay, the more I think about this, and as I rose up, I did less real statistics, more thinking, more strategy. This is the basis, the foundation of our official statistics. Representativity. And you know what? According to words, representativity is not a word, but I'm going to use it, okay? That is the most important thing. What we do as statisticians or statistics, it makes inferences or educated guesses about the unmeasured characteristics of a population. Okay? So I talked about CPI. I don't know what the real inflation rate is, okay? If we could measure it, then you wouldn't need to do the CPI. I wouldn't have to go to stores and get prices and blah, 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 blah. It's there. So our job is to, with the data we have, to make an inference on something about the population of interest. So I contrasted the two. I said, okay, I have these two definitions. Let's take a look at them. How are they different or how are they similar? This is my personal opinion, okay? So if you don't agree with me, please, we can have a discussion. Data analytics is good for identifying things of interest. Okay? Dashboards and visualizations are really, really good to say, okay, looking at this, I need to work on this. Okay? The question I have in my mind as a statistician, well, what are the levers? I need to work on it, but what does it mean? What can I, change here, change there to improve that outcome? Statistics tries to explain why things have happened. And this is correlation versus causation, all that kind of stuff. This is a little bit about that. This is really useful if I want to influence outcomes. For me, the most important differences of statistics includes the collection of data. Okay, now I'll touch on that a little bit in a couple of slides. It makes inference to the population of interest. And sometimes it uses very complex statistical modeling, which doesn't mean that deep learning, neural nets, they're very complicated as well. They're, in my mind, not a statistical model. Okay, so there's a slight difference there, a nuance. So, I should have just said, I'm going to talk about one precondition allows this to happen. And this has been mentioned quite a bit here in the last couple days. You have to have quality data. Okay, so I said high quality. But what does it mean? I've heard this term floating around a couple times, and I'm not sure that we don't all have the same understanding of what does it mean to have quality data. And more importantly, how in the world do we get it? Okay, that's what we're here. We're all data-driven, right? So, what does quality mean? Frameworks exist. Go to ChatGPT. Okay, I pulled a couple only because I'm familiar with them. The UN Statistical Mission has frameworks on data quality, sometimes quality assessment. Eurostat has it. The Office for National Statistics in the UK has it. The Australian Bureau of Statistics, they have one. Okay, tons of overlap. Okay, so they're not all different. Of course, I work at StatCan, so I'm going to talk about ours. Okay, so we have what we call the quality guidelines. We define quality in 6 dimensions. Okay, these aren't necessarily any order of importance, but I'm going to go through them. Accuracy and reliability. What does accuracy of statistical information means? It means that it can properly measure the phenomenon it's designed to measure. Okay, it'd be kind of crazy if I said, okay, this is the unemployment rate when in fact I'm measuring prices. It doesn't make any sense. Okay? Reliability is a really important part for me as a statistician. This tells me that over time, if I keep doing this, I'm going to be usually around the truth. Okay? For those that, if you talk about variances, okay, reliability is a measure of spread. Okay? If you want to estimate this point, and you've heard of confidence intervals and prediction regions or prediction error prediction, I think. You don't want, your variance to be huge, because that tells you you're this somewhere in here when the truth is somewhere in here. You'd like to be really, really, really close. And again, for me, representativity is essential for accuracy. If I have a sample of only males, okay, can I estimate for the females? Can I estimate for the entire population? Well, if your entire population is only males, yeah, no problem. But if you've got females, and then now you've got, transgender and the non-binary, I can't do anything with just a sample of males, right? Timeliness and punctuality. So for us, the timeliness of statistical information deals with when is the data available and how long after the reference period. Okay? Interpretability. This is links to AI. We've heard a little bit about here in AI. You have to be able to explain how things are done. Okay? There's a lot of work being done on explainable machine learning and all that kind of stuff. Same thing, explainable AI, interpretability, explainability are very similar. Coherence and comparability. If you want to compare things, the concepts have to be coherent. I better speed up here. Accessibility and clarity. Okay? What good is data if people can't get it? And even if they can get it, they don't understand it. Okay? So that's another one of our dimensions. This is really important in terms of LLMs. Okay? I'll say it. StatCan has a horrible website. Okay? If you're looking for something from StatCan, don't go to the website. Google it. It'll take you to our website. Okay? I've said this internally, so before you start thinking, oh my God, what's that? Okay? We're looking at using LLMs to layer over. There was a talk yesterday, I don't remember the gentleman's name, talked about doing SQL queries through LLM. Great way to do things. Okay, IMF is doing the same thing, except they're using something called SDMX. It's another standard. Relevance. Well, if the information isn't what people need, then what's the use? So, we're sitting here and you're sitting here going, oh, you know, Wes, this is great for official statisticians. I'm not an official statistician. We don't produce the CPI. We don't produce unemployment rates. So, you know, what good is this to a lot of people? Well, you may not be doing that, but the principles, I think, are important. So I want to talk about the principles. A lot of the data, I think, that's being used in data analytics, I call it found data. Okay? You can call it primary versus secondary, use whatever language you want. A lot of it is administrative. Julian's talk, I know you're here, Julian. I said I was going to point him out. Your talk's about HR data. That's administrative data, right? That's not collected for statistical purposes. That's collected to match the people and the jobs. This is what Julian keeps telling me, right? To find out, who's doing the work, who's doing what work and where? Did I get it right? Close enough, okay. I'm a statistician, I only need to be close. So, so it's not collected for statistical purposes. Importantly, a lot of times we have no control over the selection or what we call the response mechanism. We have no control. We have no idea why you think of data as a block of data. We call it Swiss cheese because there's holes in the data, right? I don't know why that number's missing, okay? I don't know why this person didn't respond, okay? We have no control over selection or response mechanism. If something's missing, okay, I don't know how that number was filled. Again, that little hole, that Swiss cheese. I have no control over the concepts measured. I don't know if that concept that was asked is the one that I'm interested in. These are challenges of using found data. We have no control over many aspects that have an effect on the quality of the data. So, what are the challenges brought on by these factors? As I said, in my mind, and this is my personal opinion, the most important part is the data covering the population of interest. If it's not, who said it? There was somebody, can't remember, I should have wrote down names. Garbage in, garbage out. Okay. I don't care if you're doing machine learning, you can do AI, you can do ChatGPT. We talked a little bit about, there was some talk about LLMs scouring the internet. Okay? If the internet doesn't cover our population of interest, don't use it. Okay? By having the data cover the population, we make inference to the right population. Okay, I'm going to have to speed up a bit here. Missing values, as I mentioned before. If there are missing values, okay, how are they handled? Right? Do we just make up a number? Do we put the average in there? Do I do what we call donor imputation, assign somebody similar and bring over their values? If imputation was used to fill in those missing values, what was done? Okay? We as official statisticians, we use what we call imputation models. We make assumptions, we assume this, that, or other thing, and then we impute based on those assumptions. Are there measures of reliability and uncertainty? This is maybe a little bit less, well, no, maybe not. How do we know if two numbers are different? And I have an example, a question in an example. If our departmental average is 70 on whatever score you want, right? We're all into the math of federal government, the management accountability framework or whatever. Got to put these indicators on, right? Oh, look, at StatCan scored is 62. What's the average? 65. Well, are we really different? Okay, or is there just noise in the data? Visualizations, heat maps, and dashboards need to take into account this variability when they do things. I have a really good example. There was, oh geez. Internally, we looked at something on PSCS, and they made thresholds. So if you were below a threshold, and I have an example here, you were considered as needing help, okay? Well, one of our assistant deputy ministers, when he saw that, he called me up and said, have you seen this? I said, no. He just freaked out, because he understands this type of stuff, right? Is 69 really different than 70? Probably not. Yet, in the heat map, it was. Okay, when integrating multiple data sources, standard or common concepts and definitions are essential. We talked a little bit. This is why we need data architects like Julian. Gotta have these concepts exactly the same. I went through some data stewardship principles here, but the most important standards or common concepts are essential for interoperability. Okay, we're all about integrating data. And I have an example here that I'll explain a couple things about it. So, example, mental health project. This is a big thing, okay? Those of you in the federal government may know of the 13 psychosocial risk factors in the National Standard for Canada for Psychological Health and Safety in the Workplace. We just call it the standard. Okay? We wanted to measure it. So we used the Public Service Employment Survey. Why did we use that? Because technically it covers all federal government employee, technically. The core administration, blah, 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 but okay, it covered everybody. We didn't just say, okay, well, just send an email to everybody. We spent months and months and months and months to identify the target population. Julian can probably attest, our snapshot of all of our employees is probably not the most up to date. I'll just say it that way. Okay. We cleaned that up. We wanted the right population. We sent reminders to non-respondents. Hey, you haven't responded yet. Can you? We emails to DMs, emails to, all these people saying, encourage your people, blah, 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 to get the response rate up. Imputation was performed by non-response, but we did it in a statistical manner. We did the imputation model, looked at assumptions, and so forth. So, I'm trying to remember one of the. I should know these factors, but I can't. I'm drawing a blank right now. I think balance is one of them. Okay, work-life balance type thing, right? How do you measure that? Okay, these are what we call latent variables. You can't measure. It's not like a height, weight, whatever. You can't measure it. So what we said is we looked at the PSES questions, and we got a bunch of experts to say, yeah, this is related. This question is related to balance. This question is related to balance. Blah 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 blah. We didn't stop there, and this is where I think our involvement in this was a big plus. In the past, they would have just stopped there. They would have said, well, the experts said this is how you measure balance. We took it a step further, and we did a statistical analysis, and we looked at the validity of these questions to measure each of the factors. Okay, we did statistical tests and everything. We were able to measure 11 of the 13 factors. We couldn't do them all. Well, that's fine. But we knew with these 11, statistically, they were measured properly. So this is, then we put it in a dashboard, blah, blah, blah. Of course, there was lots of other work that was done. This is a snapshot of the dashboard. This is actually a snapshot of my field, not my field, the field that I'm in. Okay, it's not my field. And this compared to the StatCan levels, green is good, orange is okay, red is well, this was sort of at the, so there's 11 factors there. The bars are the field that I'm in, and the line is the StatCan result. So it allows us to compare sort of where we stood compared to StatCan. It's not important to read it. That's not my point. I just wanted to show that. This is just trends over time. So if you go back to, and in fact I have a little typo here, our field is doing quite well in comparison with StatCan. Okay? Except for that one little red one, right? Remember, it was called organizational culture. Well, if you look closely, our field score is 59.1, and it's red because their cutoff was 60. Okay? So we're like 0.9 points away. So this goes back to my question about reliability, measures of uncertainty. Is it really red? Is 59.1 really different than 60 or 60.1? Okay? So that's why it's important to have estimates of uncertainty. What this does, though, is it shows us areas where we need to work on. Okay? Also shows us where we're doing well. We don't need to, well, we should never stop working on it, but it's not as important. I was told to mention this by the Center of Expertise for Mental Health in the Workplace. From a mental health lens, the performance of the factors, okay, every outcome. Okay, so if you look at that and you do good scores, everything is good. Yeah, okay, I agree. But me as a stats geek, the million-dollar question was, how can I use this to influence outcomes? This is great, right? Yeah, but you know what? This is what it was in 2021 or 2022 or whatever. I want to make a difference. So suppose I want to influence the outcome job satisfaction. That's one of the questions on the PSES. Overall, I like my job. What can I do? How do I make that better? What we did is we fit a statistical model, and we said, okay, which of those 11 factors influence the answers to this question the most. And what we found it was involvement and influence was the highest factor. Involvement and influence was measured by questions 13, 14, and 15, okay, on the PSES. You guys can probably read it better than I. I'm getting old, I can't read that. It's too small for me. So what we talk about is an impact model. If I want to improve the outcome, overall I like my job, I should be concentrating on this factor because this had the largest influence. This factor involved these 3 questions. So what do? I design actions to improve the scores of those 3 questions. Okay? And that should, technically, improve the outcome. Another example, net new hires. The objective of the project is to attract net new hires. Okay, so you're thinking, oh yeah, this is when I first heard, oh, that's easy. Just look at who was hired, after such and such a date, and blah, 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 we're good to go. We had, 3 or 4 different departments involved. We were trying to bring all their data together, a data integration project. They all had their own ideas of net new hires. Okay, the data was not very clean. We spent, we spent the majority of the work on the project trying to figure things out, cleaning up the data, but most importantly, arriving at working definitions. Some of the examples, extensions and reappointments. The government, you hire somebody, if the reference date is April 1st, if somebody is on contract before that, okay, but their contract ends and then you turn them indeterminate, is that a new hire? I don't know, right? So we had to talk a lot of stuff about that, extensions and so forth. We had people start in one department on this date, their contract was supposed to end here, then they appear in the data of another department before their actual contract ended. So it looked like they were employed in 2 places. Lots of work had to be done. This is an idea about concepts and definitions, standardization. So, quick summary. You're all being asked to use data. You're all being asked to use data for decision making, right? Who in this room is not being asked to do that? Good, nobody put up their hand. So you at least know what your bosses are asking you, okay? You're gonna continue to be asked that, okay? Even if there's a potential change of government, this government that we have now, big pushes for evidence-based research or evidence-based policy making. I don't think it's gonna change, okay? Whether the government continues or whether there's a change of government, it's not gonna change. What I'd like to share with you guys is be careful. Don't take all dashboards and visualizations at face value. Okay? You as an executive, you're just going to come up, you're going to get this dashboard, and you're going to be looking at it, and they're going to say, okay, what do we do? What do we do? Consider the quality of the underlying data. Ask questions. Okay? You don't have to be an expert to ask questions. Ask questions. Dashboards are good for some things, but not everything. Okay, our former chief statistician said they're backwards looking. This is what happened in 2023, okay, because it takes that long to get the data, right? Well, there's a lot of stuff that happens in a year, in particular in the government, in particular in today's society. Okay? So they highlight areas of concern for what I really also like to point out is, to me, that's your first step. Take a look at your dashboard, make sure the data is okay, make sure the underlying data is solid foundationally. Okay, you got the right representativity, blah, 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 blah. Look at where your areas that need work. Now you need to get back into the data and do some deep statistical analysis. Well, no, do some statistical analysis. It doesn't have to be deep, okay, to figure out how you can influence the outcomes. Okay, so that's kind of my message. I don't know if anybody's buying into it or not, but anyways, we have 5 minutes for questions, or did you want to manage that? Oh,
Yeah, I think there's probably quite a few questions, so yeah, we'll bring you the floor for questions. Yep, right.
I do. Okay, is this on? Hello. Okay, there. Okay, I could talk to you all day about statistics, right? One of the things I find is there's an over-reliance on a significant finding, like statistically significant difference from people that don't understand stats. Because sometimes I have census data. I have the injuries for all employees. I have them all. And I kind of blame Stats Canada for this, because when I say the word, I have census data, they tell me, oh, I'm not talking about the population of Canada, I'm talking about employees. And I go, no, census data is not the, yeah. So I say I have census data, so you can't do a stats test. The answer is, it is what it is. So when they ask, can you run the stats test anyway? My answer is usually, a test of statistical significance is saying whether that difference is reliable. It's not telling you whether or not it's important. So to me, there's always two questions when you have it. The first one is my data reliable? And if you have census data, you know it is, because there's no margin of error. The census is what it is. But if you have a random probability sample, you have to do the stats test. Okay, now it's reliable. Your second question is this big enough, a difference big enough to be important to my business or important for making decisions? Because you can have a statistic, if you have a big enough sample, you can have a significant difference that's tiny, you know, 71 versus 75, and you're going like, that's really not going to make a difference in my business. Yeah. So anyway, just, I find that sometimes I get asked to do stats tests on things that it's a census data. So how much time do you spend, maybe not at Stats Canada, explaining stats to?
So first of all, there's another census. Just kidding. Your points are really, really good. So when we talk about census, there's no sampling error. Okay, but I would look at other sources of error. There's something we call total survey error. Okay, so when we do a census, you need to look at the edits, verifications of, okay, do the data make sense? Okay, you should be looking at outliers. Okay, I would really look at coverage. Okay, you got to make sure your coverage is correct. So do you really have everybody, every event covered? Okay, if you do, then you're talking more about reliability, as you said. What will happen, you can do a statistical test, you can calculate the variance, but if your n is really, really large, your variance is like this, everything becomes significant. So I understand where you're coming from. I would stay away from the statistical test and say, look, there's no sampling error. We've validated all of the other potential sources of non-sampling error, because that's what you have, and we feel very, very comfortable with what we have. Okay, that's the way I would go. Okay, can't remember your second question, sorry.
A lot of people don't understand margin of error and think that margin of error is a test statistic.
Yeah, so what we produce when we do our official statistics, we call it coefficient of variation, which you can do as a confidence interval. I still remember, when I was in university doing tutorials and stuff, this whole concept of a confidence interval is a little bit weird because, again, we're getting a little bit technical here. It's the whole idea of repeating something many, 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 many times. It's probably not what you think it is. It's just got to be transparent, and we got to use layman's terms. Okay, and this is, in my mind, one of the most difficult, not difficult, one of the, not even rare, it's a characteristic that we really, really value at StatCan. If you can get somebody that can explain a complex statistical methodology, and this would go back for data science, right? AI and you know, LLMs and stuff like this, okay? If you can find these people that can really explain that to my mom or my dad, okay, keep them, because they're gems, right? LLM, what does an LLM do? It's a statistical model that predicts the next most likely word. That's all it does. So when I hear that, oh, LLMs understand things, no, they don't. Okay? It's all statistics. It's a model that says, if I see this word, you know, these three words, well, based on what I've read on the internet, good and bad, the next probable word is, I don't know, the. Okay? A lot of times it's right. Okay? Why do you think if you ask the same question twice, you don't always get the same answer? Doesn't that bother you guys? To me it does, sorry.
Yeah, I think we have time for one more question. Just here.
Thanks. Great talk. One question I had was, I wonder if at StatsCan you accompany some of your quantitative assessments with certain qualitative assessments as well. Like, I'll take inflation as an example. Like, let's say you're able to estimate that inflation is at 1.6%, but do you consider like doing root cause analysis that's also able to say, it's here because of, let's say, grocery stores being greedy versus something else, because you're like, oh, we did a correlation analysis. In the past, oil prices were always correlated with groceries, and now they're down, but groceries are still up. So, you're able to provide that qualitative assessment alongside the inflation number as well.
No, we don't do that. That would go against our mandate.
I see.
Okay, so we try not to interject our opinions and so forth, even if it is qualitative. Okay, we leave that up to the analyst looking at, not outside of StatCan, right? The economic analysis and analysts and so forth. We don't want to go down that route. Okay, sorry. Our ethics people might not really like that either. I'm being told to wrap up. So I hope that you all got something out of this. Like I said, this is not my typical type of talk, and I wasn't sure what to target, but thanks for having me, and
This was
I hope you have a
excellent. Thank you so
great
much,
rest of the
Wesley.
day. Do you want this, or?